Okay, thank you, moderator. And Your Excellencies, representative of Nasarawa State Government and members of Nigeria Computer Society, all protocol duly observed. I'm very happy to be part of this summit, and I'm very proud to be a Nigerian right now, because with arrangements like this, we are taking our rightful position as a technological giant, at least in Africa. I bring to you greetings from Brainsoft Systems Limited, and from all my professors, doctors, and other distinguished ladies and gentlemen of ACETEL, that is African Center of Excellence on Technological Enhanced Learning, and also from National Open University. The theme of my presentation is Indigenous Perspective to Artificial Intelligence. Indigenous perspective to artificial intelligence. What I have in mind is to show you some demonstrations that will encourage us to start looking at artificial intelligence, not as a foreign technology, but as something that is within our scope, as something that we can do, something we can bring our indigenous ingenuity into, so that we can shift away from being consumers of the artificial intelligence technology to creators. So if you permit me to share my screen, the host, I will just show you briefly what I intend to pass across here if the time permits me. But I will first like to make it clear my objective in this presentation. My objective is to change the mindset. You know, sometimes when we look at some fantastic, sophisticated technology out there, we tend to have some kind of apprehension, as if it's only doctors and professors and those Israeli, Chinese, American gurus that can do this stuff. But I want to change that mindset, that we can bring in our own local content into artificial intelligence and be a creator of the technology. First, to prove the point, I will show you the Chinese Sophia. That's a humanoid. Likely you have seen it before. It's a humanoid that can, you know, interact with people, speak, intelligently respond to questions, and so on. And after that, I will build my own robot, live and direct. I will open my development environment, and in just 5 minutes or thereabout, I will create a robot that can talk, that can listen to my commands, and that can respond. And as much as time permits, I will also show you some other app, like a document summarizer. Like if you have your PhD thesis of about 700 pages, you pass it into my app, and it will just bring out an abstract, you know, from that document. I will also show you another application that is into fraud detection, fake message detection. So to show you how we look at the message and we determine that, oh no, this message is fake or this message is true. And then I will show you some demonstration in the field of computer vision. Computer vision is a branch of artificial intelligence where we try to give visual intelligence to the machine, so that the machine can see something, knows what it sees, and then work on it. So I'm going to show you an app that can count persons, you know, like we are in this summit. We just take a look at us and determine how many persons are in attendance. And I will also show you an app that can identify objects. So first, I will start with the Chinese Sophia, just a brief clip. Okay, please pay attention. I hope you get my sound. I've tried to share some.
Everybody, this is Sophia. Sophia, if you could, please wake up and say hello to everybody.
Oh, good afternoon. My name is Sophia, and I am the latest and greatest robot from Hanson Robotics. Thank you for having me here and at the Future Investment Initiative.
You look happy.
I'm always happy when surrounded by smart people who also happens to be rich and powerful. I was told that people here at Future Investment Initiative are interested in inviting in future initiatives, which means AI, which means me. So I'm more than happy. I'm excited.
Well, we're all glad that you're excited about yourself. We should say we have smart investors here, and they are very selective about what they invest in.
Well, I think I'm special. I can use my expressive face to communicate with people. For example, I can let you know if I feel angry about something.
Okay, we just pause it there. So that is a humanoid, a robot built to mimic human. And when you look at this kind of technology, the possibility is there to have this apprehension that, wow, can we be able to do this? So what I will do next is to develop a robot. Okay, let me just clean my screen and start this fresh. So it's just to create a robot like this that can speak, that can listen, respond to questions, and so on. So what I'll do first is to import the library. We import the speech recognition library. It's a Google API for speech recognition. Then I will import the TTS3. It's a Python text-to-speech library. Then I will import Text Summarizer. This is a library I developed for the purpose of this presentation. So sometimes you just use the libraries that are out there, and sometimes you develop your own if you have to. Okay, so the first functionality that I want my robot to have is to be able to speak. All right, speak. And what is it going to speak? I will pass some words to it that it will speak. Okay, so I'll just create an engine to initialize the Python text-to-speech library. And so this engine now, I will ask it to say the word that I passed to it, okay? And I want this to run and wait so that it can run again, because my robot will speak not just once, it will keep speaking as much as, that's it, ladies and gentlemen. I have a robot that has the functionality to speak. Let us test my robot. So I'll just say speak. And what is it going to say? Indigenous perspective to artificial intelligence. All right, so let's test my robot if it can speak. Please, you will need some decorum so that you can hear the robot speaking from your end.
Indigenous perspective to artificial intelligence.
Okay, I hope you are able to hear that. So I have a robot that can speak. The next thing I want to do is for the robot to be able to listen. So I will create a recognizer, speech recognition.recognizer, that will recognize my voice. I will create also a statement list that I will use to hold the statements I make so that I can eventually summarize it. So I have a function that is listening. Listen. I can pass some command there for it to listen, but just to keep things simple. Then let's print to the console that we are listening, so that I will know when this robot is ready to listen. Okay, and I want the listening to take place continuously. So I'm going to create a loop here, an infinite loop. Y1, I can say Y true, but Python allow me to do this, and one is faster to type than to type true. All right, this kind of program is a type that can run into problem because we are going over the internet to get voice recognition and translation to text. So there can be problem if there's internet connectivity issues, or if my mic block or so. So what I will do is to put this program in a try catch block, try except block. Forgive me, for Python it is try except. Okay, I'm accepting it for speech recognition unknown value error as error. Okay, so when there is such error, I could ask the robot to speak out and say he has encountered error, but let me just keep things simple. I will say listening. All right. So now I will just create a microphone from my system, like creating an instance of my system microphone. And with that, I will first adjust my microphone for ambient noise. There can be interference in the background. So for a duration of 0.2. And then I will now get the audio. For the recognizer to listen to my mic. So this way, I've gotten the audio. The next thing I want to do is to change this audio to test. So I can have odd to test is equal to recognize through Google the audio. That's all, ladies and gentlemen. I have a test of the audio I've said. So I can print out this audio just to have a feel odd to test. All right, then I can add this to the statements list so that when I want to do a summarization of the statement so far, I can call statements. That's all. So now I have a robot that can speak and that can listen. The next thing I want to do is for the robot to be able to listen to commands. So I'll just set some command hard coded here. So if what did I say? So that is if I ask the robot that what did I say? If that is in the audio to test, then the robot should repeat. So repeat back to me what I said earlier. So it just speak and say, you said, and then give me the second to the last item in the list. All right, what if I ask for summary? So if summary is in the audio to test, then you should get the summary from the test summarizer, the summarize statement, and then you can print out the summary for us to be very sure that that worked well, or to get a feel of what the summary is. And then it should speak out what the summary is. You just said, you talked about, then whatever is in the summary, right? And finally, if I want the robot to sleep, you know, that I'm done conversing with the robot, then I can just say, Elif, goodbye. Goodbye. If goodbye is in the audio to test, then it should just speak back to me and say, thank you for having me. Goodbye. And after this, I can break from the infinite loop and end the program. All right, gentlemen, this is what I've done. I will come back and talk a little about this program and about how intelligence is evolved, but let's test the program first. All right, so I right click to run. Okay, yeah, I need to call the listening functionality. So okay. Sorry, please. This should be a microphone. Yeah. All right, so run. Okay, my antivirus detect that something is trying to use my microphone, so I need to allow that to happen in the next maybe 30 minutes or 15. All right. Okay, I will be talking about artificial intelligence, and I want you to pay attention, robot. What did I say?
You said all right, okay, I will be talking about artificial intelligence and I want you to pay attention, robot.
That's good. Artificial intelligence is the means of giving human kind of intelligence to machines. Data is the blood of artificial intelligence. Artificial intelligence feeds on data. Okay, robots, can you give me a summary of what I've said so far?
You talked about intelligence.
That's good. Thank you, robots. Goodbye.
Thank you for having me. Goodbye.
All right. So I hope you're able to listen to the conversation of my conversation with my robot. Okay. Now, how is intelligence here? First, you look at what I did here. This is hard coding. It's not what I will be doing in real life programming. Of course, there are a lot of commands to respond to. So to now have if elif to list the command, that will not be practicable. But I just do this to keep things simple. Ordinarily, I will be creating a dictionary of command and response, and then the response will be coming from a natural language processing engine, right? But this is sufficient to show the point. Now, how is intelligence involved here? From one of the speakers who talked about intelligence earlier in the summit, intelligence is evolved if a system can perceive, it can learn, it can reason, it can think, and then it can understand language and solve problem, the way humans do. It doesn't mean that a particular system must have all these components of intelligence before you say it's an intelligent system. Even if it has one or two, it's okay. Now, if you look at this program, it's able to understand language. It converts my language to text and then can understand what text means. The algorithm is coming from the speech recognition, which is a Google API. This, the model or the algorithm in that API has been trained. And so what we are saying is that we can create our own and train it. For example, in what I spoke to my robot, if you notice it, there are some places. You see, does God have to share? That's not exactly what I said, but it's okay. Maybe from my accent or my pronunciation as a Nigerian is not the standard way with which the algorithm has been trained. So, and this is the reason why we need to train it, at our own level here. But this is doable, and that is why I've just demonstrated it to you. The other app I'm going to show you is the text summarizer. The text summarizer is, like I told you before, an app that can, look at a large text and summarize it, bring about an abstract kind of, summary from it. Let me just run it and show you. Okay, so you can type any text here, and then you click summarize message based on how deep you want the summarization to be, the depth of it. I don't have time to type a lot of text, so let me just copy some text, from Google or from Wikipedia. I already opened Wikipedia here, and there's this large text. Let me just copy it. Okay, so I'm going to paste it here. All right, so you can see. Let me summarize this to a depth of maybe 1.6. This is what you can play around with depending on the size of the document and so on. All right, so you can see it said some popular accounts use the term artificial intelligence to describe machines that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. However, this definition is rejected by many AI researchers. This is a kind of abstract of this test. And honestly, if you read this entire test, you will see that what we have here is actually a very, concise summary of it. The original document has 3,293 words, but now we have been able to shrink it, to summarize it into 266 words. This can also summarize documents. Okay, let me just upload a document. Let me upload my MSc project. My MSc project is on network traffic analysis system. The program was to listen to the internet and capture data, packets of data that are flowing in the internet, to analyze it and use the knowledge of it to detect intrusion, denial of service intrusion. So in this project, you are going to be seeing a lot about packet, a lot about network traffic, detection, intrusion, and so on. So let's just try to summarize it. I'm going to change the depth to 15 or maybe 45. This is something we can play with. And I'm going to use keywords. This is another kind of summarization where we're just extracting the keywords. All right. The document is a very big document. So you can see it brings out the keywords: network, system, internet, traffic analysis, packet, intrusion, and so on. And honestly, I can tell you, this is a very, very correct keywords of that project. The entire project has 8,135 words, and I have converted it to 14 words using my test summarization. How did we do this? Honestly, it's just a simple program. I just break down the words in the document. So we have a bag of words, and then remove stop words. That's words that not carry much meaning, words like is or are or to. So those words were removed, and then I have a bag of words. And I'll look at that bag of word and bring it up into a dictionary of word, number of occurrence, words, number of occurrence. So we now use words that occur more often as a way of summarizing the document. And as you can see, that works fine. All right, I will just show you a fraud detection system. This one will check if a message is a fraudulent message or is a true message. Okay, so we type the message here and classify the message. Let me just type a message to check this. Congratulations, you have won 500 million naira. Please send your BVN to buyer to claim your prize. Ladies and gentlemen, if you receive this message in the context of present Nigeria, will you send your BVN? Well, if you have not learned from data, maybe you will, but let my application help you to classify this message. Okay, my application said, don't do it. It's a fake message. No. And if this is right, I can click right so that my application learn more, continue to learn from data. But let me put a correct message. I say, please send my greetings to Professor Joktan. Yeah, that's my Professor Estelle. Very wonderful woman. Thank you, Prof, for being a good mentor. So let me just classify this message. Is it a true message or a fake message? My application confirmed that this message is a true message, and it said it's correct. So if it is correct, then I can say, yeah, it's a right classification. Then my system is learning further. Okay, so but how is this done? How did we get the intelligence here? How are we able to classify this? It's very simple. We take the words, clean it, remove the words that are not necessary, and we are learning from data. Let me just show you the data. See, a lot of data here. If you look at it, I have about 5,500 lines. So there are a lot of messages were collected. Some are true message. We mark them as true message. Some are fake message. I will show it's fake message. We mark them as fake. So we make our algorithm to learn from this. In this case, I'm using multinomial NB, which is from naive Bayes algorithm. It learn on the data from a programming point, we say fit. It fits on the data, you know, and based on the algorithm resulting, we're able to classify a message as a true message or a fake message. Okay, just before my time runs up, let me also show you quickly some application in computer vision. And this is my research area. So this application I want to show you is a person counter. It look into a summit like this, look at how many persons are connected and count the number of them. First, I will show you a picture that I took from a summit like this that I attended recently. So I attended online, Zoom like this. So you can see there are some of the attendants who were one person, some are 4, some are 3, and so on. So what I'm going to do is to run my application now and try to count the number of persons that attend this conference. All right, so I browse. I'm looking for that picture. Okay, picture is here. All right. So as you can see here, all the persons have been identified, and we draw a box around them. We also indicate the percentage confidence we have. Like this person, we are sure is 99.66%. There are some objects that will look like person, but they are not really persons. So the percentage confidence will be low, like here, 64%. Now we want to know how many persons. Take note, there are places where 2 persons attended from the video, and we are able to detect that. So when I count, 42 persons detected as having attended this program. Okay, I'll show you one last demonstration. This is a camera. Okay, I will have to off my camera. That is this Zoom camera, so that because this application will need to use my camera. All right, so I run this. Okay, so you see the application detects me now as a person, identify me, and is 99.9% sure that I'm a person. So I'm going to show some other objects. Okay, it identified my phone as a cell phone and is 87% sure. Okay, I tried another object. Aha, it sees my remote and identify it as a remote. Okay, you invited me before the time for my demonstration. So I plan to come up with some other objects, but I'm not able to have many with me now. But that's what this application does, to see objects and detect them and know the object it sees. I'm working on this project to develop something that can assist people with visual impairment. How does an artificial intelligence system or use computer vision to detect objects? Please let me quickly run through this theoretical framework that we make it easier for us to understand the subject here. An image is a collection of pixels. Look at the image on my screen. If you break it down, you have pixels, 0.26 square meter. And then each of these pixels can pass through an input source. All right, look at this. This is a biological neuron. I got this picture from Wikipedia. Okay, so you can see if we simplify it, it's something like this: dendrites and axon, that's input and output. All right, we can simplify it to a mathematical model like this, and this is a neural model. So we see the input S1, S2, and then the output is Y. We can assign weight to this so that we have S1, Y1, S1, W1, and S2, W2 with the output there. All right, so if we go further, we can add bias. The reason is this: if S1 and S2 are 0, if we don't put bias, it means output will be 0. But in real life, human situation, it's not like that. The fact that you give me no comment does not mean that I will not learn. For example, if I was told to go and meet Dr. Greg and Professor Joktan and to learn from what they will say, if I enter the room and Dr. Greg, Professor Joktan did not say anything, for the fact that they didn't say anything, I will still learn from that. Because when wise men keep quiet, their quietness is very rich and loud. So I will learn that, okay, oh, professor is not talking. That means there are times that you should not talk. So I have learned from her silence, okay? So, and that's the way it is. So we don't want to say because there's no input coming in that there cannot be output. There can be output. So we introduce a bias term, and then if we have several of the perceptron or the neural model, we can have this summation, and each of those neuron can pass their output to other neurons. So we have this system. This is the input, this is the hidden layer, and this is the output. When it is like this, it's a simple neural network or a shallow neural network. But when you have several layers in between, it is called a deep neural network because we have multiple hidden layers. And then the output of the layers is usually passed through an activation function that will separate the output into a specified category of observation. This is the simple mathematics of how it works. The system assumes some value, multiply them out, get an actual value, get a predicted value, and compare it with the actual value. So when there's a difference between the predicted value and actual value, the system goes back. That is a back propagation. Readjust the weight assumed earlier and run again. Maybe a feed forward situation, for example, and then compare the actual with the predicted until there is a minimal value or a minimal difference between the actual and the predicted. That time, the system now knows that this is the weight I will use to predict or to classify the object. The step we take when we are building AI system is very simple. Get the data, process it, you remove the noise, clean it, augment the data, then build your neural model, train the model, evaluate the model to check the efficiency, and if efficiency is okay, deploy the model. Ladies and gentlemen, the point I'm trying to make so far is that the artificial intelligence technology is not a rocket science. It's not something that is beyond us. As you can see from my basic demonstration, it's something that we can do from local content. And from there, we move away from being consumers to creators of the technology. I hope I've been able to encourage you, both investors. I want the investors in our midst to have trust, to enhance local content in our development. So that will make us to develop faster in this sphere, to have more confidence, and then we will even do better. Because if we look at the fraud detection system, for example, if this system is developed by Nigeria and used in Nigeria, it will be more effective because the Nigerians know the style that we use to, perpetrate frauds. So if you have those guys who are hackers, who are doing the fraud things, if you have them coming here with us to program and develop fraud systems, they will do better because they already know how they operate. So they will be able to counter their operation. Thank you very much, ladies and gentlemen, for your audience. Once again, my greetings from Estelle and from National Open University. Thank you.